2.3 Chemical bonding and electronegativity. Electronegativity is the ability of an atom to attract electrons, bonding electrons to itself. This diagram, figure 2, shows the periodic trends for electronegativity, and note that they are opposite trends for the trends for atomic radius. So the larger the electronegativity, the smaller the radius of the atom. Take a look at fluorine. Fluorine has one of the highest electronegativities of all the elements on the periodic table. The alkali metals have some of the lowest electronegativities of all of the elements on the periodic table. We can use electronegativity difference to predict whether or not a bond is ionic, covalent, or polar covalent. When determining whether a bond is ionic, we are looking for a large electronegativity difference. By large, we mean an electronegativity difference of greater than or equal to 1.7. If you take two atoms and subtract their electronegativity, and their electronegativity is 1.7 or higher, then you know that an ionic bond will form between those two atoms. We can determine whether a bond is molecular when the electronegativity difference is 0. Then we say that the bonds are non-polar covalent. Should be equals. So non-polar covalent bonds form when the electronegativity difference between two atoms is 0. Two identical atoms, since they have the same electronegativity, their electronegativity difference will be 0, and they will form non-polar covalent bonds. Polar covalent bonds are formed when the electronegativity difference is small. That is, when the electronegativity difference is between 0 and 1.7. If the electronegativity difference is between 0 and 1.7, then a polar covalent bond will form between two elements. Hydrogen and chlorine will form polar covalent bonds. This means that they don't share electrons equally. The atom with the higher electronegativity attracts electrons away from the atom with the lower electronegativity. The chlorine atom is therefore surrounded by a localized negative charge, or a negative pole, and we indicate that with a sigma and a negative sign. At the same time, the hydrogen atom develops a positive pole. We represent this negative and positive pole with the sigma symbol and a plus for positive and a minus for negative. Let's summarize ionic bonds and covalent bonds. Ionic bonds form between ions. Covalent bonds form between atoms. Ionic bonds are created by transfer of valence electrons between atoms to form ions. Covalent bonds are created by sharing of pairs of valence electrons between atoms. Ionic bonds result in large crystal lattices, and covalent bonds result in individual molecules. Please try any practice problems related to this section.